Hello everyone. In this video we're going to do activity 5.4 in Jamovi. So in this activity we have a small data set with just 10 people, and in this particular example we have 10 people who participated in a health at every size program. So the purpose of this program is to teach people to engage in healthy behaviors and encourage them to engage in healthy behaviors and not worry so much about what their weight is. So people focus on exercise, eating good nutrient-dense foods, getting plenty of sleep, and things like that. So in this example, people followed this program, and then 6 years later, the researchers measured their weight and wanted to know what effect following this program had on people's weight. So in this case, positive numbers indicate that somebody gained weight over those 6 years. Negative numbers mean that somebody lost weight during those 6 years, or at the end of those 6 years. So we're going to do a single sample t-test, a one sample t-test here, to see if the weight change differed from zero. So we're moving weight change over into the dependent variables box. And note here that our test value is 0, which is appropriate. We want to know whether or not the weight change differed from 0. We're also going to ask for the mean difference with confidence intervals around it, and effect size with confidence intervals. And I'll also get descriptive statistics with plots here. All right, so in this case, we have a mean number of pounds is 6.5. That's a positive number, which means on average over 6 years, people gain 6.5 pounds. The median was 10. The standard deviation is 8.77, which means the typical distance each person was, or average was, from the mean was 8.77. with a standard error of 2.77. That's a typical distance we would expect sample means with a size of 10 to be from the population mean. So we computed a t-statistics of 2.34 and got a p of 0.04. That p would be fairly strong evidence against the null hypothesis, suggesting that the difference we're observing is probably a real difference. It's likely to be a real difference. If we want to look at the size of the effect, we can look at the raw scores. So our mean difference is 6.5, and we're 95% sure that the true mean difference there is somewhere between 0.23 and 12.77. Yeah, a pretty wide confidence interval. If we look at the effect size D, which is our standardized effect size, we get an effect size of 0.74, which is a pretty large effect. But the 95% confidence interval shows us that that could be anywhere between plausibly between 0.02 and 1.43. So basically between a very, very, very small effect, negligible effect, to a very large effect. And that difference, that wide confidence interval here, is coming from the fact that we have a very small sample size. Right? So although our p-value is fairly low, this isn't terribly compelling evidence against the null, given that we have a really small sample size and such wide confidence intervals. We're not feeling terribly confident in these results. Okay. Now in this activity, we do two different test values. One of them is comparing the sample mean to 0. Do people gain or lose more than 0 pounds, right? Which is one legitimate research question to look at. But suppose the researchers know that on average people gain a certain amount of weight during a 6-year time frame. Right? So in this activity, we ask you to change the test value to 12. Let's say it's known that people gain on average 12 pounds over the 6 years in this particular age group. So if we change our test value to 12, you can see our mean, median, and so forth stay the same, but our test statistic changes quite a bit because we're comparing 6.5 to 12 rather than 6.5 to 0. Okay. So you interpret the output in the same way as you did before, but the point here is noting that the test value you choose matters a lot, right? It's typically theoretically driven, and in this case, depending on your research question, either number could make a lot of sense. So that is what you need to do for this particular activity. Okay, good luck.